Sauropterygia is an extinct, diverse taxon of aquatic reptiles that developed from terrestrial ancestors soon after the end-Permian extinction and flourished during the Mesozoic before they became extinct at the end of that era. When the End-Cretaceous extinction event occurred, only a single lineage, the Xenopsaria, represented by the two groups Elasmosauridae and Polycotylidae, was still present. Sauropterygians are united by a radical adaptation of the pectoral girdle, designed to support powerful flipper strokes. Some later Sauropterygians, such as the pliosaurs, developed a similar mechanism in the pelvis. Origins and evolution. The earliest Sauropterygians appeared about 245 million years ago, at the start of the Triassic period. The first definite Sauropterygian with exact stratigraphic datum lies within the Spartian division of the Olenkian era in South China. Early examples were small, semi-aquatic lizard-like animals with long limbs, but they quickly grew to be several meters long and spread into shallow waters. The Triassic-Jurassic extinction event wiped them all out except for the plesiosaurs. During the early Jurassic, these diversified quickly into both long-necked small-headed plesiosaurs proper and short-necked large-headed pliosaurs. Originally, it was thought that plesiosaurs and pliosaurs were two distinct superfamilies that followed separate evolutionary paths. It now seems that these were simply morphotypes in that both types evolved a number of times, with some pliosaurs evolving from plesiosaur ancestors, and vice versa. Classification of Sauropterygians has been difficult. The demands of an aquatic environment caused the same features to evolve multiple times among reptiles, an example of convergent evolution. Sauropterygians are diapsids, and since the late 1990s, scientists have suggested that they may be closely related to turtles. The bulky-bodied, mollusk-eating plecodonts may also be Sauropterygians, or intermediate between the classic Sauropterygians and turtles. Several analyses of Sauropterygian relationships since the beginning of the 2010s have suggested that they are more closely related to archosaurs than to lepidosaurs. The cladogram shown hereafter is the result of an analysis of Sauropterygian relationships conducted by Neenan and colleagues in 2013. The cladogram shown hereafter follows the most likely result found by an analysis of turtle relationships, using both fossil and genetic evidence, by M. Astley, in 2013. Size and ecology. Each morphotype filled this specific ecological role. The large pliosaurs, such as the Jurassic Romuliosaurus, Leopleurodon Pliosaurus, and the Cretaceous Kronosaurus and Brachiogenus, were the super-predators of the Mesozoic seas, around 7 to 12 meters in length, and filled a similar ecological role to that of killer whales today. The long-necked plesiosaurs, meanwhile, included both those with medium-long necks, such as the 3 to 5 meter long Plesiosauridae and Cryptoclididae, and the Jurassic and Cretaceous Elasmosauridae, which evolved progressively longer and more flexible necks, so that by the Middle and Late Cretaceous the entire animal was over 13 meters in length, although as most of this was the neck, the actual body size was much smaller than that of the larger pliosaurs. These long-necked forms undoubtedly fed on fish, which they probably snared in the tooth-lined jaws with rapid lunges of the neck and head.